Okay, hello my little hash browns. Hopefully yesterday after your lesson you worked out this problem like I asked you to, and you found the GCF using prime factorization for these three numbers. So let's go ahead and work on them real quick and see if you solved them the same way as I did. Okay, so first number is 45. Prime factorization, I'm creating a factor tree. The first thing I do is look for the lowest prime number that goes into the number. So 2 does not go into 45, but 3 goes into 45. 3 is a prime number, so I'm going to circle it. And if 3 is a factor of 45, 3 times 15 equals 45. So 15 is a factor. Oops, sorry, don't circle the 15. 15 is a factor of 45. Okay, so I'm done with the left branch. Now I'm going to continue and I'm going to work on the right side. And again, 2 doesn't go into 15, but 3 does, and it's prime. And 3 goes into 15 5 times, so 5 is also a factor of 15. And 5 is also a prime number. So I am done with 45. Now, 75. Once again, I know that it's 3 and 25. 3 is prime, so I'm going to circle it. 25 is going to be 5, and that's prime, times 5, and that's prime. And finally, last one, 120. This one I can use a 2. And 2 goes into 120 60 times. 2 is prime. I circle it. 2 times 30 gives me 60. 2 is prime. I circle it. 2 times 15 gives me 30. And I circle my 2. And then 3 times 5. And both 3 and 5 are prime. Okay, so now my prime factorization for 45 is 3 times 3 times 5. For 75, I have 3 times 5 times 5. And then for 120, I have 2 times 2 times 2 times 3 times 5. Okay, and then remember I'm looking for just the prime factors that they share. So first of all, I can tell they do not share any 2, so I can skip all that, right? Okay. Now over here I have a 3. Over here, I have a 3 for 75, and over here for 120, I have a 3. So I can circle all those 3s. Over here, I have a 3, but I don't have any more 3s for the 75, and I don't have any more 3s for the 120, so I don't circle it. For 45, I have a 5, so I look at the 75, I have that, and then I have a 5 there. So I circle a 5 for each of them. Okay, so that means my common factors are going to be GCF equals 3 times 5, or the right way would be 15. Okay, hopefully you came up with the same numbers. Okay, now I did tell you I wanted to show you a couple of word problems today just so you could see what a greatest common factor word problem would look like. So now I'm going to show you that. Okay. Give me a second. I'm going to try and make the text a little bit bigger for you. Okay. So we're going to work on number 2. All right. Number 2 says... There are 40 girls and 32 boys who want to participate in a relay race. I have the hiccups all of a sudden. If each team must have the same number of girls and boys, what is the greatest number of teams that can race? How many boys and girls will be on each team? Okay, so 2-part question. First part, how many teams can we make? So that is finding the greatest common factor. So the first thing I'm going to do is, it's only 2 numbers, so I feel like we should just list the factors for this one. It'll be easy to list the factors for this. So for 40, I've got 1 goes into 40. 1 times 40 equals 40. Gonna move this a little so you can see it all. There we go. That's better. Okay. So I've got 1, and that's 40. I've got 2 and 20. Does 3 go into 40? No. 4 goes into 40. Does 5 go into 40? Yeah. Okay, so those are my factors for 40. Then I'm going to do 32. 32. Okay, 1 and 32. 2 and 16. What about 3? Does 3 go into 32? Nope. How about 4? 4 into 32. Yeah, that works. 5. Nope. 6. Nope. Okay, so I can stop. 7. We know it doesn't work. Okay. All right. So now I circle my common factors. I've got 1 and 1. I have 2 and 2. I have 4 and 4. I don't have 5. I have 8. 16, nope. 20, nope. 32, nope. 40, no. Okay. So my greatest common factor is 8. Okay. But that's not what the question asked for. It said how many teams can each have. Can I have? So I can have 8 teams. And then the second part of the question asked how many boys and how many girls. Well, for that, all I need to do is come over here. Remember, it was girls and boys. So for girls, what factor did I multiply by 8 to get 40? And for boys, what factor did I multiply by 8 to get 32? Sorry. It was 4. Okay. So that's my answer right there. Okay. Now we're going to take a look at another one. Where is it? There it is. Okay. Okay. So for this one, number 3 we're doing. For number 3, Ming has 15 quarters, 30 dimes, and 48 nickels. He wants to group his money so that each group has the same number of each coin. What is the greatest number of groups he can make? And how many coins from each will he have in each group? How much money will each group be worth? Okay, well, let's see. Let's do prime factorization for these ones. Okay, so we're going to do factor tree. So for quarters, I have 15 quarters. I'm going to go up a little bit. Where's my problem? There it is. Okay, up a little bit. Okay, prime factorization. 2 does not go into 15. 3 goes into 15. 3 goes into 15 5 times. So both 3 and 5 are factors, and they're both prime. So I can stop. Okay, well, 30 dimes. 2 goes into 30. It goes in 15 times. And then I've got 3 times 5, and those are prime, and I can stop. And then I need nickels. Nickels is 48. So 2 goes into 48 24 times. 2 is prime, so I circle it. 2 goes into 24 12 times. Circle it. 2 goes into 12 2 times. Circle it. And 2 goes into 6 3 times. And I circle both because they're both prime. And now I know I can stop. Okay, now I'm going to set up my prime factorization. So I've got 3 times 5. And for dimes, which was 30, I have 2 times 3 times 5. I'm going to move it up a little bit. And then for my nickel, which was 48, I have 2 times 2 times 2 times 2 times 3. Okay. Now I am going to look for all of my common prime factors. So common, I have a 3 here, and I have a 3 here, and I have a 3 here. Okay, well, now if you look, I only have 3, right? Because there's no other common prime numbers. So that means my GCF equals 3. So remember, they wanted to group the money. How many groups can we have? We can have 3 groups. And then I'm going to fold this for a second so that we can see the question better. Okay, so I've got 3 groups. And then it says how many of each coin will be in each group. Well, if 3 goes into 15 5 times, there will be 5 quarters. And 3 goes into 30 10 times, so it'll be 10 dimes. And 3 goes into 48 16 times. So that will be 16 nickels. Okay, now I need to know my money values. Oh my goodness. So I've done the first part. That's the first question. This is the second part of the question. And then we've got the third part of the question. The third part is how much money is in each group. Woo! Okay, so 5 quarters. Each quarter is worth 25 cents. 5 times 25 is 125. So that's $1.25. Okay. Dimes. Dimes are worth 10 cents. I've got 10 dimes. 10 times 10 cents gives me $1. Okay. Whew. Lord. 16 nickels. Nickels are worth 5 cents. 16 times 5 gives me 80. So that's 80 cents. Now I just have to add it all together. So that's 5, 10, carry the 1, 3. So each group has $3.05. That was a lot of work for that word problem, right? That was definitely EOG style. Okay. All right, I hope that made a little sense for you. You got to be on your lookout for the word problems. They're going to pop into assignments and stuff, and you have to be prepared to be able to identify these problems. All right, have a good day. Don't forget to go do your freckle math.